Welcome to Practical Statistics for Nursing using SPSS. This video shows how to process the MANOVA test. You can watch the entire video or use the time slider to navigate to any time point. The MANOVA test is quite similar to the ANOVA test. Before proceeding, it's recommended that you first view the video ch06anova.mp4. In terms of setup and results, the MANOVA and ANOVA tests are quite similar. We've already seen that the ANOVA test can compare the effects of 3 different drugs on systolic blood pressure. But what if we also wanted to see how these drugs affected another dependent variable, such as pulse rate? Whereas ANOVA can process only one dependent variable, such as systolic blood pressure, MANOVA can process additional dependent variables, such as pulse rate. In this example, we'll see that the results of the MANOVA test will look like we ran 2 separate ANOVA tests, one for systolic blood pressure and another for resting pulse rate. The MANOVA test has 5 pre-test criteria: N quota, normality, moderate correlation, homogeneity of variance-covariance, boxes M test, and homogeneity of variance, Levine's test. We'll check for the first 3 now. We'll see the results of the remaining 2 when we run the MANOVA test. This example uses the dataset CH08 example 01 manova.sav. This dataset contains 3 variables. Group is a categorical variable that contains 3 values: drug A, drug B, and drug C. Systolic BP is a continuous variable that contains the systolic blood pressure of each participant at the conclusion of the study. And pulse is a continuous variable that contains the resting pulse rate of each participant at the conclusion of the study. We'll begin by checking for the N quota. Click on Analyze, Descriptive Statistics, Frequencies. Move Group to Variables and click OK. The frequency table indicates 30 participants per group, hence this criterion is satisfied. Next, we'll check for normality, starting with drug A, Group 1. Click Select Cases, click If Condition is Satisfied, click If. In the dialog box, enter Group equals 1. Click Continue, click OK. Now order the histogram with normal curve for systolic BP and pulse. Click Analyze, Descriptive Statistics, Frequencies. Move systolic BP and pulse into variables. Click Charts and select histogram with normal curve. Click Continue, click OK, and it'll process. The histograms for systolic BP and pulse are normal for Group 1. Next, repeat the process for drug B, Group 2. Click Select Cases, click If. In the dialog box, enter Group equals 2. Click Continue, click OK. Now order the histogram with normal curve for systolic BP and pulse. Click Analyze, Descriptive Statistics, Frequencies. Click OK, and it'll process. The histograms for systolic BP and pulse are normal for Group 2. Now repeat the process once again for drug C, Group 3. Click Select Cases, click If. In the dialog box, enter Group equals 3. Click Continue, click OK. Now order the histogram with normal curve for systolic BP and pulse. Click Analyze, Descriptive Statistics, frequencies. Click OK, and it'll process. The histograms for systolic BP and pulse are normal for group 3. The normality criterion is satisfied. Before proceeding, reactivate all the records. Click on Filter $$ and press the Delete key. Now we'll check for moderate correlation between the two continuous variables, systolic BP and pulse. Click Analyze, Correlate, Bivariate. Move systolic BP and pulse to variables, and click OK. The correlation between systolic BP and pulse is 0.339. Since this is between 0.3 and 0.9, this satisfies the criteria of moderate correlation. To run the MANOVA test, click on Analyze, General Linear Model, Multivariate. Move systolic BP and pulse to dependent variables, and move group to fixed factors. Click on Post Hoc, move group to Post Hoc tests. On the Equivalent Variance Assumption option, check Bonferroni. Click Continue. Click Options, move group to Display Means, and check Homogeneity Tests. Click Continue, click OK, and it'll process. To finalize the pretest checklist, we look to Box's test of equality for covariance matrices, which rendered a p-value of 0.703. Since this is greater than 0.001, this indicates that there is no significant difference between the variance covariances in this model. Hence, this pretest criteria is satisfied. Levine's test of equality of error variances shows a p-value of 0.656 for systolic BP and 0.765 for pulse. Since these p-values are greater than 0.05, this indicates that there is no statistically significant difference among the variances for the two dependent variables. Hence, this criterion is satisfied. Proceeding with the results of the MANOVA test, we look to the multivariate test table. We see that Pillai's trace rendered a p-value of 0.003. Since this is less than or equal to 0.05, this tells us that a statistically significant difference has been detected among the pairs of groups for the outcome variables systolic BP and pulse. Finally, we look to the multiple comparisons table to determine which group performs statistically significantly different from which. The estimates table provides us with the means for each group for systolic BP and pulse. These figures will be useful when documenting the results. Notice that the multiple comparisons table essentially resembles two ANOVA multiple comparisons tables, wherein the top half of the table shows the three pairwise comparisons for systolic BP, and the bottom half shows a separate set of comparisons for pulse. To identify which groups outperform which for each of the variables, begin by identifying the pairs of groups that have a p-value that's less than or equal to 0.05 for systolic BP. Then, do the same for pulse. This concludes this video.